Okay, question number 1. The ordered pairs in this set shown below are of the form xy. In which set is y a function of x? So in order for a set to be a function, every x has only one y. So let's check it out. 1 gives you 3, so 2 gives you 6, 3 gives you 1, and 6 gives you 3. So every x has only one y. So it should be this one. Let's just be really certain and double check. So 1 gives you 3, right? 3 gives you 1. Whoa, 3 gives you 4. So take a look here. That means if x is 3, right? If x is 3, y can be 1 or 4. So that means this x can have two different y's. So it's not this one. So let's try another one. Just to make sure. 0, y is 3, x, y is 4, 2, y is 4, 2, y is 8. Whoa, so that means if x is 2, y can be 4 or 8, right? You see that? This, when it's 2, it's 4, or it can be 8. So this is not one as well. And let's do this last one here. Just to make extra certain I did this right. X is 1, y is -2. X is 1, y is 0. So that means if x is 1, y can be -2 or it can be 0. That means this x has two different y's, so it's not this one. So this is the best answer. That's correct. Okay, let's take a look at this one here. It's saying a function consists of 5 ordered pairs of the form xy. 4 of the ordered pairs are here. Which one could be the 5th? So let's go ahead and put 1, 49 here. If 1, 49 is added, would this be a function? Well, take a look here. We have x is 1, y is 9. But if we add this one here, we also have x is 1, y is 49. So that means if x is 1, y could be 9 or 49. So once again, every x is only supposed to have one y. If I put this one here, that would not be the case. So that is not one of my answers, or that cannot be an answer. Okay, so let's try 3, 9. So if I put 3, 9 here, let's see. Wait a minute, I have a 3 here. When x is 3, y can be 19. And when I add this one here, or it can be 9. That means this x has two y's, so this is not a function. We cannot add that one and it still be a function. Let's try 5, 19. So 5, 19, 5, 19. Let's check it out. Oh, wait a minute. We have this 5 here, and when x is 5, y can be 29. And if I add this point here, it would be 19. So that means when x is 5, with this added ordered pair here, y could be either 29 or 19, i.e. this x would have two different y's. So it's not that. So hopefully it's this last one. Okay, so this last one we're going to try is 9, 8. So let's check it out. I have 1 and 9. 3, 19, 5 and 29, 7 and 39, and 9 and 8. So in this case, every x has only one y. So this is the answer. All right, so the elements of a function x are 4, 1, -2, 0, and 8, -1. What is the range? So just a little reminder, domain are all inputs and they're the x values, or the first, right, of the ordered pairs. You also have range, which is your outputs, and also your y coordinate. So let's take a look at this. Our y coordinates, we want range, so we're looking at the y coordinates. We have 1, 0, and -1. So it is this one here. Okay, so let's take a look at this. We want the domain, so we're looking at all x values of the coordinates. So let's take a look. We have this point here. That point is -3, 0. Then we have this point here, which is -2, 4. We have this point here, which is 0, -4. We have this point here, which is 3, 2. And those are all 1, 2, 3, 4 points. So they want domain, so we're looking for -3, -2, 0, and 3. This is our answer.